Good evening, friends. Welcome to 360DigiTMG. Today we are going to discuss about AI-powered image generation topic, which from the past few weeks we are continuing. So on the today's part, we are going to understand about the SDXL Turbo tool. Okay, for creating a text format into the image generation format. Okay, so here SDXL Turbo is a fast and efficient text-to-image generation model. So what it does, it is built on a foundation of stable diffusion model. A stable diffusion model, which is an SDXL 1.0. It will generate a photorealistic images, which will be based on a textual description. Whatever the textual description or a prompt you will describe or you will provide, that will be dependent on that, and it will generate images. It achieves a real-time image generations through a technique called adversarial diffusion distillation, ADD. This essentially trains the model for faster image synthesis as compared to the original SDXL model. So a stable diffusion XL base model leverages the image generation capabilities and which is useful or which is powerful than that of the SDXL 1.0 model. Okay. And second thing is our adversarial diffusion model, which is an ADD model, which is a innovative training method which will allow us like SDXL turbo model to achieve high quality image generations. We want not only images, we want a high quality image generations in just 1 to 4 steps, efficiently reducing the processing time as well. So while excelling in the speed, SDXL Turbo might not always match the image quality achieved by the original model. It lowers the SDXL model in certain situations as well. Now, let's see its working, how it works. SDXL Turbo leverages in stable diffusion XL models. It builds on powerful image generation capabilities, which is existing stable diffusion model have. Okay. And it also acquires the faster synthesis as compared to that of ADD with ADD. Okay. So it has a high quality image generation capabilities in just 1 to 4 steps compared to that of the SDXL model, which was a base model. So it has a real-time text to image generation format or tool. So this faster processing translates to real-time image creation, which will be users can receive a photorealistic images almost instantly based on the text prompt or based on that whatever the prompt they are providing. So let's see the working of SDXL turbo model. So in our traditional diffusion models, what occurs? Let's see inside what occurs. So it has a standard diffusion models which works by gradually adding some noise. Okay, it gradually added some noise in the image. Okay, to an image until it becomes a pure noisy image. Then they learn to reverse this process starting with the noisy image and progressively removing the noise and creating a clean coherent image. This process can be computationally expensive, especially for the high quality image generation. Okay, what they are doing, they are just adding, firstly, they are adding noise gradually. And once the noise is like pure noisy image will be generated, then they are starting to remove this noise and make the image clean. Okay, then what is ADD? ADD takes a different approach. It involves two models. First is of teacher model and second is of student model. So teacher model is a pre-trained model, which is a powerful diffusion model, which is like a stable diffusion XL. Okay, this model excels at generating a high quality images, but What is a drawback of this? It is a slow model. Since it is a big model, it is computationally, it will take some time. It is slowly processed. So what is its replica then? There is a student model, which is a smaller version of this teacher model, which is faster model in case SDXL turbo type. So ADD, that is adversarial diffusion distillation, trains the model to mimic the output of the teacher models in the much fewer numbers of steps, typically 1 to 4 steps. So this a training model, a training process. What is it in the training process? It will have a teacher model. Okay. The teacher model will generate a high quality image from a text prompt. Then the student model tries to predict what the noisy version of that image would look like. Then a special adversarial training techniques will be there, which will compare the student's prediction with the actual noisy versions created by the teacher models. It will compare, adversarial network will compare between the teacher model as well as the student model. Then there will be student. The student model will then refine its prediction based on the comparison, essentially learning how to efficiently add noise, that the teacher model can effectively remove that noise during a image generation. So this is our SDXL turbo model, which is having a student and teacher architecture. So what are the benefits of ADD? Adversarial diffusion, distillation. This is the main part here. So what are the benefits of this? It is faster image synthesis. It has a reduced computational cost. Okay. Then there is applications and benefits of this SDXL model. So these are all the applications are of SDXL Turbo, which is an interactive design, rapid prototyping, live storytelling, real-time image creation, accessibilities, and improved workflow. Then we have a Pika model. Now, in this Pika model, we have an AI-powered video, which is a tool developed by Pika Labs. It utilizes a generative AI models to transform the concepts like images or existing videos into the engaging and creative video content. The underlying technology powering the Pika 1.0 is not publicly disclosed, okay, but it likely involves generative AI models, which is trained on vast data sets of text as well as video pairs. See the functionality, the features of this model and this Pika 1.0. So the functionality is it is an AI-powered video creation and editing tool. Inputs, what we inputs we can it can take a text prompt input, it can take a images or the existing videos also. What are the capabilities? So here idea is to video generation, style transfer, and content editing within the videos. Then there are certain benefits of these models like simplified creation, enhanced creativity, and streamlined workflows. Okay, so let's see. Then there is Florence 2 model. This Florence 2 is developed by Microsoft's Azure's AI team. Florence 2 is a cutting-edge foundation model which is designed to revolutionize the field of computer vision. It is a next generation vision foundation models which is designed for deep visual understanding and versatile applications across multiple vision tasks. It features on an innovative architectures that effectively handles complex visual data, enabling it to grasp the detailed spatial and semantic nuances. It utilizes the large-scale data sets for multitask learning. It improves its adaptability and performance across a varieties of vision challenges. Then it achieves the states of art results in foundational mutual task. It demonstrates the exceptional zero shot and fine tuning capabilities. Okay, so this is what? This is for the Florence 2 model. Let's see the architecture of this model. So this is a model foundation. See, in the Florence 2, we have a unified prompt-based representations for a diverse computer vision and vision language task. It will accommodating the complex spatial hierarchy and semantic granularity. It is a multitask learning step up, which will leverage a large-scale, high-quality annotated data sets. Okay, just like FLD 5B with a 5.4 billion annotations. It has been annotated on 5.4 billions. Okay, across 126 million images. So the total data set consists of 126 million images. Out of from that, 5.4 billions has been annotated for a comprehensive multitask learning. It has a sequence-to-sequence structure. The model will be deployed on a sequence-to-sequence architecture, okay, which will integrate an image into the encoder and a multimodality encoder-decoder, which will handle the versatile vision task effectively. Then we have a prompt-based task instructions. Florence 2 uses the text prompt as a task instructions. It will use a desirable output. It will generate a desirable output in the text form for tasks such as captioning or object detections or segmentations. Okay, it can be used for the prompts which we are providing. It can be used, it can be give instructions and it will generate the prompts according to the given image. Okay, for example, if we want for captioning the image, it can do like that also. For object detection, it can do for that also. For image segmentation, yes, it can be helpful for that also. Then there is automated annotations and model refinements. The model iteratively refines and enhances its capabilities through an automated annotation process and a model refinements, utilizing the FLD 5 billion datasets for training. This is our dataset. Okay, it will have a vision encoder. It will use a vision transformer. It will utilize the vision transformer as a vision encoder, which will convert or input images into the flattened usual token embeddings. Okay, it will first take our image, it will convert into the embedding format, numerical format, converting the images into the pixel intensity values and making into the token embedding format. It will process further for the task specific output. Whatever is the task, it will use according to that task. Then multimodality encoder decoder, what it does. So this component process will visualize and it can be used for language tokens embedding, which will concatenate them for comprehensive multimodal understanding and response generations. Okay. So it can be used for captioning and other things. We can use it for that. Then there is how it works. So, for example, there is a example scenario. Imagine an image depicting a scene where a person is riding a red bicycle on the road with a red car in the background. The road is lined with trees and another person is seen riding in a bicycle in front of the first person. Okay, there is one date also. That is 22nd September 2023 is visible in the bottom right corners of the image. Okay, now what we want, this is our text. Okay, now what we want to create this text into the image format, generate the image format. So what we'll do, we will take our image input. It will Given image is an input in the Florence 2, which starts processing the visual contents using its image encoder format. Then the vision encoder processing, what it will do, it will generate, or it will used based on the vision transformer architecture. It will transform the input images into the series of flattened visual token embeddings. Then these embeddings will capture the essential visual features of the scene. Okay. And after that, there will be third step, that is a task instructions while text prompting. Then this text prompt acting as a text task instructions is provided to the model. This is what is our we want as a text input. Depending upon the desired output, okay, it will generate. The prompt guides the model on what way of the information we want to generate the image. Likewise, okay. So we are taking our vision transformer architecture. We are using the visual token embeddings from that architecture. And what we are setting our prompts in the instruction format in the model itself, and we want to guide that text to generate the image. After that, what will be there? There will be generating desirable outcomes for captioning purpose. If you want it for the captioning purpose, see, it has been generated. Okay, this has been generated. So for captioning, the model might generate a comprehensive description. The image shows a person. See, the all content is here. Then for object detection, the model will identify and locate the key objects within the image, such as the person, bicycle, car, trees, providing their bounding boxes coordinates. See here, we have provided the bounding boxes and with the confidence as well. Then for visual grounding, what we are doing, it would link specific phrases from the description to corresponding the regions in the images, like phrases, a person riding in the red bicycle. So it will take that and it will make some changes in this. Okay. So the person riding in red bicycle on the road, it will only give the focus on that point. Okay. And for image segmentation, what it will do, instead of creating the bounding boxes, we can use a masking. Okay. So here in the segmentation, we'll do the polygon masking. Then there is multimodality encoder-decoder processing. So the combined visual and text embeddings are further processed by the multimodality encoder-decoder architecture. Okay. This step will emphasize the visual features and the task instructions into the coherent output that matches the prompt. Okay. It will see what is matching with the prompts. Okay. So after that, the output generation will be there. Based on the task instructions, Florence 2 will generate the appropriate outputs in the text form, which could be a detailed caption, or it could be an object bounding boxes with the labels as well. See here, object bounding boxes with some labels here. It can be like this also, or association between the text phrases and the image regions. Okay. So as we can see, the Florence 2 examples. See, the image shows a model home office set up with the 2 wide desks. See, all description has been there. What is the condition? The condition is to give the prompt appropriately. Okay, so that our model would not hallucinate. Okay, we have to give the desired prompt or accurate prompt. That is the need. Okay, so see, these are all the text prompts, and according to that text prompts, we have seen the image is being generated. Okay, then see the prompt. Locate the phrases in the captions. What is in the caption? So it has been there, like 1, 2, 3, 4, likewise. Okay, it will fetch from here what is there in the first place. So it will give the first place to this. Likewise, what will be there in the second place? Second is the cheese. So slice of cheese is the second bounding box. Likewise, we have to give the captions to these things over here. Okay. So this is one of the example of Lorentz 2 model. This is also one of the example. See what we are giving. We are giving the prompts and we are giving the bounding boxes with some descriptions. Here also we are giving the bounding boxes with the instructions, some of the parts. So this is how also we can use it for what is there inside the image. See, this is the prompts, and according to this prompt, the images which is in the text format also, it can extract the features from that. Okay, and generate the features according to that also. So after that, there is one more tool for generating the image, which is a cog agent. Okay, so it's a powerful visual language model, VLM, designed specifically to understand graphical user interface, GUI, like menus, buttons, and windows on your computers or phone. Okay, what it does, it is specifically designed specifically to understand the graphical user interface, GUIs, like menus, menu buttons, and windows on your computers or phone. It will analyze the screenshots or live views of the GUI. Okay, graphical user interfaces. It will identify the elements and their functionalities within the applications. Okay, so it goes on a step further by understanding the relationship between the UI elements, which will potentially enables the navigation and interactions within the GUI, graphical user interfaces. The potential application of this is it can use for automating the software testing, accessibility tools for visually impaired users, and it can be used for improved GUI design based on the user interaction analysis. A recent research project with promising capabilities, but still under development for wider applications. Okay, so this is one of the applications, and still the research are going on this side. Then there is, it has the cog agent. The architecture of this model is trained on 18 billion parameters, specialized in GUI understanding, supporting up to this much image pixels. See, for detailed recognitions of task and small elements. It will have a dual encoder architecture, and it is having a cross attention mechanism. Okay, so first it will combines the two resolution encodings for generating the features as well as high resolution encodings for fine details. Then it has a cross attention mechanisms, which will features both the encoders to the balanced detail recognitions. Apart from that, there is a pre-trained model on GUI data. Okay, so specifically pre-trained on our data sets with the GUI images, graphical user interfaces images, and the OCR data, optimal character recognition data sets, which will enhance its GUI interaction capabilities. Then it will use for the high resolution adaptation. It is designed to efficiently process the high resolution GUI images. Okay. Then it efficiently focuses on strategies which are reducing the computational overhead. So see, just move the cursor to the Google search box located approximately at the center of the screen. Likewise, it can guide us. Could you guide me through the steps to search the best papers in CVPR 2023? So likewise, it can tell us this is the first step, second step, third step, and the fourth step. Okay. Then could you guide me through the steps to change the display mode to the light mode? So see how it is telling us actually. and it has been changed. All the guidelines are telling. Okay. So it is making our life easier. This cog agents. Okay. So see, it can be used as a chatbot also. Then what is the conclusion of this? This is a groundbreaking performance. Cog agents achieves a state-of-art results in graphical user interfaces, understanding, and navigations. It outperforms existing models across its multiple benchmarks. It includes those of the detailed recognitions of text as and GUI elements. It has a efficient high resolution processing. Its innovative architectures combining the dual encoders and the cross attention mechanisms. It will allow for efficient processing of high resolution images. Okay. And the broad applicabilities and open source. Okay. It can be used cog agent. Cog agent also sets up a new standards in general visual question answering challenge. Okay. And the model and its code are open sourced. So we can also, there's an open source. So we can also use it for our application or our business problem. Then there is scaling open vocabulary object detection models. Okay. So this is an object detection task. It can be used for object detection task. It has a scaling open vocabulary detection task, which will tackle the limitations by enabling the detections of unseen or novel objects categories. Okay, so we have to set our open vocabulary, which will refer to the ability to detect objects from the unbounded sets of categories. Not just those including the training data, but we should have a model that can potentially detect any objects which encounters, even if it wasn't explicitly trained on that specific type of object. Then there is scaling, which will highlight the goal of achieving this open vocabulary detections at larger scales. Then there is a traditional closed vocabulary object detection model, which is a large quantities of label data for a specific categories, specific open categories. See, these are some of the examples related to this. It will have a pseudo annotation generation. It is using a pre-trained detector, which is a vision transformer L14, which will analyze an image and generates a bounding box annotation based on the text captions, like in n-grams. Okay. So this step will leverage the image associated with text to create a rich sets of pseudo annotations that will cover a wide label shapes. Then we have a self-training. We can use it for self-training as well. It can be useful for pseudo annotations to train the new models. It can be used for effectively transforming the original open vocabulary detectors into the enhanced versions. The self-training process will allow the model to learn from the own predictions. Whatever the predictions they are giving, it can be learned from themselves, and iteratively improving the detection capabilities. Or otherwise, what we can do it for fine-tuning as well. Our business problem, we can use it for fine-tuning purpose. So this self-trained models can be further fine-tuned on our data sets with human annotations to refine its understanding and improve the detection performance on specific classes or in objects. Okay, so this is a pseudo annotation. Okay, and in the fine tuning, what we are doing, we are trying to manually we are doing annotation. Okay, human annotations is being done here. Okay, so this step is an optional, but we can lead to significant improvement in detection the accuracy. Okay, after that, it will generate, okay, what is the output? By utilizing the web scale image text pairs for self-training, we can use it for substantial improvements in open vocabulary object detection task. So, for example, we can use it for self-training, fine-tuning the models, average precision, mean average precision, or anything like accuracy or whatever the matrix we want. Okay, on a rare class, whatever the class which is not present, we can use it for that rare class. Okay, it is using this data set, LVIS data sets, which is significantly increases, showcasing the effectiveness of scaling up and detection task with weak supervisions and self-training. Okay, so this is it. We have understood of the all the image annotation tools. Okay, so all of these we have gone through. Okay, first we have started this stable diffusion, then mid journey, clip, blip 2, vision transformer, DALI 3, imagine, stable diffusions, EMU, and SDXL. Today we have seen SDXL, then we have seen Pika, then after that we had seen Florence 2, cog agents. Okay, and this is just we are seeing right now. Okay, the scaling of open vocabulary object detection, we have recently gone through this. Okay, so this is it, guys. I hope you like this lecture. Thank you for joining. See you in next lecture. Thank you.